Hello, this is Laur Fisher from MIT's Climate Change podcast. Today I learned climate, and today we're taking on a question from Abraham G. of California, who asks, how clean is green hydrogen? Now, if you haven't listened to our episode on hydrogen energy, I really do recommend that you pause this and listen to that one first. It will help give you some really important context for this conversation. But to give you the 30-second version, hydrogen is often touted as a potential clean fuel of the future because it can be burned like oil or gas, but without releasing climate pollution. And because we can burn it and produce a lot of heat, hydrogen can do things that other clean power, like wind and solar, doesn't do that well, from powering ships and planes to providing the high heat needed in steel mills. Here's Dr. Emre Gençer, a principal research scientist at the MIT Energy Initiative and our hydrogen expert for this episode.
The reason we are talking about hydrogen is because there are sectors of the economy that are hard to electrify. We need some other way to decarbonize these sectors, to run them without producing carbon dioxide or other climate warming emissions. And that's why we use the hydrogen as a solution. But that completely depends on how clean our hydrogen production is.
The trouble is that while hydrogen is clean when we burn it, before we get to that point, we have to find some pure hydrogen. And there's actually very little of that on Earth. So we extract hydrogen from other naturally occurring molecules. And that extraction can cause climate pollution. And that brings us to this funny little color code that folks use to describe hydrogen. Gray hydrogen, black hydrogen, brown, blue, green. It's funny because it's not like the hydrogen itself is a different color. It's just a way to shorthand describing how the hydrogen was produced. Okay, so let's dig in.
Currently, in the US, 95% of hydrogen is produced from natural gas, or methane, through a process called steam reforming. We call this gray hydrogen. But with gray hydrogen, during production, you are emitting a huge amount of carbon dioxide. And this is just the fact of chemistry. Because you start with methane, which is made of one carbon atom and 4 hydrogen atoms. And if you extract the hydrogen from that, the remaining carbon is going to react with oxygen and become CO2.
So gray hydrogen doesn't help us address climate change at all because it's just burning fossil fuels. The same is true of black and brown hydrogen, which both come from carbon-rich coal. But there are other colors in the hydrogen spectrum. One is blue hydrogen. You take regular old gray hydrogen, but instead of venting the CO2 into the air, you use some clever chemistry to trap that CO2 and pump it underground, which is a form of carbon capture and storage. Dr. Gençer actually participated in a 2022 study of blue hydrogen to learn how successful it was at stopping CO2 emissions.
What we found was if you have gray hydrogen with no carbon capture, you are actually producing about 12 times as much CO2 as hydrogen. And if you have blue hydrogen, where you add carbon capture, you can get that down to 3 to 5 times as much CO2 as hydrogen. So the difference is quite substantial.
So while blue hydrogen emits less CO2 than gray hydrogen, it still emits a bunch of CO2. And is that any better than just burning fossil fuels? To answer that question, let's imagine that you're an airline considering switching from jet fuel to hydrogen. First, this isn't a simple switchover. For just one thing, hydrogen holds less energy per gallon, so your planes will actually need to be redesigned with bigger tanks. But would that hydrogen be cleaner than jet fuel? Well, if you use gray hydrogen, which is the kind that you produce from the methane in natural gas, the answer is no. You'd be producing at least as much CO2 per flight as you are with jet fuel, and quite possibly more. But blue hydrogen could be 3 or 4 times less polluting than jet fuel. So a plane running on blue hydrogen should produce less climate pollution than a normal plane. Just not, unfortunately, zero pollution. But Abraham, you asked us about green hydrogen. And here we're looking at a totally different process and level of potential as a climate solution.
Green hydrogen is hydrogen produced from renewable power. So you have devices called electrolyzers, which split water molecules into hydrogen and oxygen. And where do you get the electricity for these electrolyzers? You use a renewable source like solar or wind or hydropower. And if you are only using solar and wind to produce the hydrogen, then you are doing this without producing carbon dioxide, because there is no carbon involved.
Which sounds great, and it is. This is a pathway to a non-climate polluting fuel. But even though your electricity doesn't pollute the climate, and your electrolyzer doesn't pollute the climate, and the water that you're taking hydrogen out of doesn't pollute the climate, we still have some pollution to account for.
So say you are making a green hydrogen using solar panels. Some carbon dioxide was produced in manufacturing those solar panels, and also in shipping those solar panels and installing those solar panels. The same goes for wind turbines. Plus, you need to make electrolyzers and whatever other infrastructure is required for your facility. So all the emissions that go into the process need to be accounted for.
And this means that green hydrogen is only as clean as the equipment that makes it. Now, here's the good news. Across many studies of green hydrogen operations, researchers have found that some of these facilities can produce more hydrogen than CO2, sometimes a lot more. You can compare that again to blue hydrogen, which makes 3 to 5 times more CO2 as hydrogen. But this can also vary quite a bit depending on a few things. For example, wind energy and certain kinds of hydropower tend to get you the very cleanest green hydrogen.
For green hydrogen made with solar power, emissions can be higher. Solar panels are often produced in China using higher emissions manufacturing, and they take more energy to produce than wind turbines.
Which means, in terms of their climate impact, some green hydrogen facilities that run on solar power are more in the range of blue hydrogen. Again, that's less pollution than, say, jet fuel, but still a good distance from pollution-free. It's not just that solar panels take more energy to manufacture than wind turbines. It's also that without energy storage, you can only make hydrogen from solar power during the day when the sun is shining.
Say your renewable energy is available around 50 or 60% of the day. The remaining hours, you are not able to operate your electrolyzers. That's a problem because those electrolyzers are very expensive, very capital intensive, and you are not utilizing their full capacity. So that drives the cost of green hydrogen very high. So to avoid that, you might choose to bring in electricity from the wider electric grid. So you can run these electrolyzers throughout the day. And that can reduce your cost because you are running continuously. But this grid electricity is probably made with fossil fuels. By definition, that's not green hydrogen. And it's going to have higher emission intensity. So it helps lower your costs, but it defeats the whole purpose of actually trying to create lower carbon hydrogen.
Which is why the hydrogen sector is looking forward to some important technological breakthroughs.
The main bottleneck is the high cost of electrolyzers. So if we get cheaper electrolyzers, you will definitely see more green hydrogen coming online sooner. Or alternatively, energy storage can become cheaper. And when you have solar electricity, you can store some for later and use it to run the electrolyzers when the sun goes down. But that really requires very, very cheap energy storage options that we don't have right now. So when you ask how we can make green hydrogen cleaner, actually green hydrogen is already very clean. The reason we don't see the full impact is because it is so hard to produce pure green hydrogen because of these cost considerations. But perhaps this will change. The US Department of Energy has set up 7 regional clean hydrogen hubs, and there are many clean hydrogen projects that will be coming online with these hubs that we can hope will be a game changer for the green hydrogen industry because now this will be demonstrated at scale.
And this is why your question matters so much right now, Abraham, because we are already investing in hydrogen. Not just green, but also blue. And perhaps some of the other colors of the rainbow, like pink hydrogen, which would be made with nuclear power. Or turquoise hydrogen, which is a different way of processing methane that produces no CO2. And if these investments are going to help us move toward a pollution-free economy, they need to support genuinely clean hydrogen.
So I think these goals are very ambitious for producing 100% green hydrogen or very low carbon hydrogen. But we should understand that this is what the future of hydrogen rests on. If the carbon intensity of the hydrogen is not low enough, then actually its role in addressing climate change is zero.
Thank you, Abraham, for your thoughtful question. And speaking of thoughtful questions, I wanted to close out this episode by responding to a listener who called into our voicemail line. We'll play a little bit of his question because it really stuck with us.
Hello there. My name is Hugh Backhurst. I have a handful of friends who have been losing, unfortunately, a lot of sleep since watching Canadian actor William Shatner's interview on Good Morning Britain, where he basically insists that we're rapidly approaching extinction. Yeah, that's a really hard thing to process, and hopefully it's not quite as grim as he made it sound. So yeah, if we could get any clarification on that, we'd much appreciate that.
Hugh, you're not the only one asking if climate change is going to drive humanity extinct. In fact, we've answered this question before on our website, climate.mit.edu, where we answer readers' questions about climate change. And I want to reassure you that no, the consensus of climate scientists is not that we are headed for human extinction or the end of civilization, even in the more extreme climate scenarios. Of course, we are expecting many serious risks, and it's well worth doing what we can to avoid them. And also, we should recognize that for some people, in some places, those risks are existential. When we spoke to a climate modeler at MIT about this, he said he is deeply worried for farmers in coastal Bangladesh, or people who live in the African Sahel below the Sahara Desert, or the citizens of small island nations. Their cultures and way of life might go extinct. But as for human extinction, like all humanity, well, when the UN put out its last big report summarizing the state of climate science in 2023, that was not even mentioned as a possibility. And we wanted you to know that, Hugh. We'll have a link to our full answer in our show notes at tilclimate.mit.edu. And for anyone else out there who has a climate question, I hope that you'll ask us. Leave us a voicemail message at 617-253-3566, or see if we've already answered your question at climate.mit.edu. TIL Climate is the climate change podcast of the Massachusetts Institute of Technology. Aaron Krol is our writer and producer. David Lishansky is our sound editor and producer. Michelle Harris is our fact checker. Sylvia Scharf is our climate education specialist. The music is by Blue Dot Sessions, and I'm your host and executive producer, Laur Hesse Fisher. A big thanks to Dr. Emre Gençer for speaking with us, to Abraham for asking us their question, and to you, our listeners. Keep up the curiosity.